All right, we are going to go over some notes here on lessons 3-6, lines and coordinate planes. So basically equations of lines. This should all be review, although there's a lot of information here. This is all algebra review. First of all, you're going to see lines, straight lines, and with these lines there's two major components. They have a steepness called the slope, and they also have where it crosses the y-axis. And there's always an equation attached to each one of these lines. It's usually y is equal to mx plus b. The slope of a line, as we mentioned, is the steepness of a line denoted by a number. The bigger the number, the steeper the line. So if you just look at this picture here, this black line, line A here, looks much steeper than line B. This one would have a bigger number. And in fact, the slope of this line is 3, or 301 across. The slope of this red line, line B, happens to be slope of 1/2. So obviously 3 is bigger than 1/2. And if you'll recall from the past, slope means rise over run. It goes up 3 spaces, 1, 2, 3, across 1. That's run. Up 3, 1, 2, 3, across 1. 3 is the slope. This one rises up 1, across 2, 1/2. 1/2 is obviously not as steep as slope 3. The equation for a slope, if you were given coordinate pairs, it would be y2 minus y1 over x2 minus x1. You subtract the y values and put that over subtracting the x values. When you subtract y values, that tells you the difference of up and down. When you subtract x values, that tells you the difference left to right. And so it's rise over run. Rise over run. We'll go over this particular formula a little bit later. Positive slopes. Now, positive and negative slope is just the direction. A positive slope goes upwards from left to right, so it will look something like this. Positive and negative slopes does not mean one is steeper than the other. It's just the direction. Negative slopes go downwards from left to right, so it will be something like this. So you could have positive 3 or negative 3. It has the same steepness, but it just shows the directions. A zero slope, as compared to no slope, the number 0 is a flat line. There's no steepness at all. An undefined slope or a no slope, or if you punch this in the calculator, it will say error. It's a line that goes so steep you can't put a number on it. You can't say, well, that's steep, so that must be 1,000,000, because there's always a number bigger than 1,000,000. So you can't quantify this. But this, a flat line, is a slope of 0. Maybe that's a slope of 1, slope of 2, slope of 3, slope of 4, and it gets steeper and steeper to the point where it gets undefined, and then it starts to go into negative slopes. Negative slopes, because negative slopes go downwards. Alrighty, there are 3 equations for slope forms here. There is the most typical one. This is the slope-intercept form here. I'll put it in this graph, slope-intercept form. This is the one we should be most familiar with. This is the y is equal to mx plus b. There should be a number for m, and that would be how steep the line is, the slope. And there should be a number like the number 5 or the number -2, but that is the b value, and this is the y-intercept, where it crosses the y-axis. Again, this is all review. This line here and this equation is an example of the slope-intercept form. Y is equal to 2x plus 3. Y is by itself. All the other information is on the other side. Standard form is where x and y are going to be on the same side. So ax plus by is equal to c. Now a, b, and c are just numbers. There doesn't mean the slope or where it crosses the y-axis. They're just numbers. So this right here is an example of what we would call standard form. You'll see x and y on the same side, the equal side. This is standard form. And then the final one is called point slope form. This is going to be y minus y is equal to mx minus x, where this represents this x and y represent a point on the line, and this represents the slope. We're not going to see this very often, but this is called the point, because there will be one point on the line, slope form. So in this case, this would be one of the points, and then this would be the slope right here. Okay. All right. Moving on. Actually, let me add one more thought here with the point slope form. this 1, 2, now you got to understand that the formula already starts with a negative x here. So this is going to be, one of the points is going to be 1 for x. And then when you turn it into a positive, if the formula has a negative, then this has to be negative 2. So if you'll notice on this graph, there is a point at 1, negative 2. So that is the 1 point there. And then the slope is 2, which means 2 up, 1 across. 2 up, 1 across, and you'll hit the line again. So that is called point-slope form. All right, let's go down over here. We're going to graph this equation. It is in what we call slope-intercept form. It's in your typical y is equal to mx plus b form. What I'm going to first do is kind of highlight an x-axis and a y-axis. This is not the biggest graph, but we don't need a really big graph. Hopefully you'll know how to use the slope number and the y-intercept number. The first thing you want to do is plot where it crosses the y-axis. It crosses at negative 2, so go down here at negative 2. All right? So the line is going to cross here. It could be like this, it could be like this, and the direction it goes will all depend on the slope. Now this slope says negative 1/2. Now you've got to recall negative go downwards, and so what you want to do is it's 1 up, 2 across in a negative direction. Now start at this negative 2 because you know you're going to cross here. Don't start at 0, 0. You can go 1 up, 2 across. Or you can go 1 down, 2 across in the other direction. But as long as, when I connect the dots here, you have a negative going downward slope, negative slope. And that's the equation of the line. Okay? We are going to go through more just algebra stuff here. They're going to flat out say, write the equation of a line that has this slope and passes through this point. Now when we write an equation of a line, we're going to put it in y is equal to mx plus b. There's two numbers that we need. We need this number here called the slope, and we need this number here where it crosses the y-axis. We know what the slope number is, so we're just going to plug that in there. And what we don't know is where does it cross the y-axis, but they do give us a point. And so with that point, every point starts with an x. The second number is a y. What I'm going to do with this 2 is plug the 2 in where the x is. The 4, I'm going to plug the 4 in where the y is. And then I'm going to solve for the b where it crosses the y-axis. So instead of y, it's going to be negative 4 is equal to the slope, negative 1 times x. X happens to be 2 plus b. And we'll solve for b here. Negative 4, 1 times negative 2 is negative 2. I'll add 2 to both sides, and you get negative 2 is the b. Now that's just the y-intercept. That is not the equation. So let's put it all together. Y is equal to mx, so it's negative 1, that's m, the slope, plus b, b happens to be negative 2. And there's your equation of this line. Okay, all equations, like this one here, can be graphed. So I actually graphed it, and you don't have to do this. But basically, here it is. Here was the original point, 2, negative 4, 2 over, negative 4 down. It has a slope of negative 1, so 1 up, 1 across, 1 up, 1 across, 1 up, 1 across. If you'll notice, there's the slope number, negative 1. Whoops, this should have been negative 1 here. And it crosses here at negative 2, right there. Crosses the y-axis at negative 2. So this is the graph. This is the equation. Same as what we just worked on. Alrighty, and then the final problem here will be in this bottom one here. It says write an equation, so that's y is equal to mx plus b again. And of course we need to figure out what the slope number is and the y-intercept number of the line that passes through this point and this point. So on the graph paper there's just 2 points, and what you're going to do is, obviously when you have 2 points you can connect the points and create a straight line. Well, this line has an equation attached to it. We got to figure out what this equation is. Now, first thing, we don't have the slope like the previous problem. They give us a slope. We don't know where the y-intercept is, so we're going to have to figure out both. The first thing we're going to do is figure out the slope. Now, this is an equation that we brought up way in the top here, in the top of our notes. So I'm going to bring it down here. This is y2 minus y1 over x2 minus x1. These 4 digits here are going to match up with one of these 4 points here. So this is xy, so I'll put an xy. This is also x comma y. If P is the first point, then I'll just put an x1, y1. If this is the second point, I'll put a little x2 there, y2. If I had a third point, I'd say x3, y3. But that's all that 1 and 2 is just distinguish which point I'm stealing the information from. So the slope formula says y2, which in this case it's -3, minus whatever y1 is, happens to be 0, over x2, which is the 7, minus, that's the formula, whatever the x1 is, which is 5. This is -3 over 2. Now that's the slope number. So my equation looks like y is equal to, instead of m, I'm going to put -3 over 2. We just solved for that. X plus b. Well, we're closer, but we're halfway done. We still got to figure out what b is. Well, how are we going to figure out what b is? You can take either point P or point Q here. It doesn't really matter because both points would be on the same exact line. But you take this 5, which is the x value, this 0, which is the y value, plug it right there. If you put the 7 and the -3, you could use those two, and you would get the same answer for b. It doesn't really matter. I'm going to put 0 here for y, 3 over 2 times whatever x is 5, plus b. And then when I multiply this out, this is 3 times 5 is 15. 15 divided by 2 is -7.5. I add 7.5 to the 0. The b value is 7.5. So when I put it all together, here's the slope, here's the b value. So y is equal to the slope, -3 over 2x, plus 7.5. That's the equation of the line given 2 point locations. Figure out the slope, then figure out where it crosses the y-axis. I actually graphed this earlier, and you don't have to do this, but here's 1.5 over 0 up, 7 over -3. Obviously, this is the line. It goes up 1, 2, 3, across 2, 1, 2. That's the slope. -3 over 2, up 3, across 2. That's the slope. And it crosses, if I look, it crosses right here, which happens to be 7.5. And that's how this formula arrives.